Now say next question from exercise 5.4, question number 5th. Find number 1, u bar dot v bar. If magnitude of u is 2, magnitude of v is 5 and magnitude of cross product of u bar cross v bar equals to 8. So first we find the first sub question. Now see here. We have provided magnitude of vector u, magnitude of vector v and magnitude of cross product. That means we have to use the cross product here. So we know the cross product, definition of cross product. So first we write the definition. If theta is angle between u bar and v bar, then by definition we write here u bar cross v bar is equal to magnitude of u bar into magnitude of v bar into angle between them. So we have to take angle between them in sine ratio, sine theta into n cap. Now see the given part here, magnitude of u bar cross v bar is given. That means we have to take its magnitude. So we write here magnitude of u bar cross v bar equals to. So here magnitude of u bar is already given. So you can write this also in this form, magnitude of u bar, magnitude of v bar, then sin theta n cap. Now you take magnitude of each term. So we write magnitude of u bar as simply u bar. So we write magnitude of u bar, magnitude of v bar, then magnitude of sin theta. So we write sin theta, and here magnitude of n cap. This n cap is unit vector, so its magnitude is 1. So we write magnitude of u bar, magnitude of v bar into sin theta into 1 as magnitude of u bar cross v bar. So we write this as magnitude of u bar, magnitude of v bar into sin theta is equal to magnitude of u bar cross v bar. Now here we substitute the value of magnitude of u bar cross v bar as 8. So we substitute the value as 8. Now magnitude of u bar is 2, magnitude of v bar is 5 into sin theta. So we calculate sin theta is equals to, now divide it by 4. So we get sin theta equals to 4 by 5. But for scalar product we require cos ratio. So we use the identity sin square theta plus cos square theta is equals to 1. So from this we write cos theta is equals to in root 1 minus sin square theta. So we have to take here cos theta equals to 1 minus, in place of sin theta we replace 4 by 5. So we write here 4 by 5 its square. So we get here 1 minus 16 by 25. So after cross multiplying this we get 25 minus 16 which is 9. 9 by 25. So taking square root we get here c by 5. So in this way we calculate the value of cos theta. Now we know the definition of scalar product, that is dot product. So write the definition of dot product. Therefore u bar dot v bar is equals to, we write here magnitude of u bar into magnitude of v bar into cos theta. So substitute the value of cos theta as 3 by 5. Magnitude of u bar is 2, magnitude of v bar is 5 into 3 by 5. So this 5 get cancelled, we get 2 3s are 6. So u bar dot v bar equals to 6 is the required solution. U bar dot v bar is equals to 6. So while writing the final answer, we have to remember the one concept here. theta is either acute or obtuse. So we write here cos theta is equals to plus or minus, because when we take square root we always write plus or minus. So we write here plus or minus, plus or minus. Here also we have to write plus or minus, plus or minus. And in this step also we write here in bracket plus or minus. That means in final we require the answer as plus or minus 6. So you can write this as u bar dot v bar equals to plus or minus 6. Now see second sub question. Here magnitude of u bar cross v bar we have to find. Magnitude of u bar cross v bar if magnitude of u equals to 10, magnitude of v equals to 2 and u bar dot v bar equals to 12. That means here dot product is provided. So by using definition of dot product we have to calculate the value of magnitude of cross product. So first we have to find the cross product u bar cross v bar. So we use the definition of dot product here first. So we write here let theta be the angle between u bar and v bar. Then by definition of dot product we write u bar dot v bar is equal to magnitude of u bar, magnitude of v bar into cos theta. Now here u bar dot v bar is given. So we write here in place of u bar dot v bar 12. So 12 is equal to magnitude of u bar is given, magnitude of u bar is 10, magnitude of v bar is given which is 10 into cos theta. So we get here 12 upon 20 is equal to cos theta. So when we divide by 2 we get here 6 by 10, that is equal to 3 by 5. Now this is the value of cos theta. Therefore cos theta is equal to 3 by 5. For cross product we require sin theta. So again we use the identity sin square theta plus cos square theta equals to 1. Therefore sin square theta plus cos square theta is equals to 1 gives we require sin square theta. So sin square theta equals to 1 minus cos square theta. So substitute the value of cos theta here. We get 1 minus 3 by 5 its square. So we write here 1 minus 9 by 25. So after cross multiplying we get 25 minus 9 which is 16 by 25. So we get here 4 by 5. Why we not write here plus or minus? Because in first quadrant sign is positive, in second quadrant also sign is positive. So from that we write here sin theta is equal to 4 by 5 and we know that angle may be 0, may be 180 or between them. So when lines angle between them is 0, so sin 0 is 0, so their magnitude is 0. So we consider here sin theta equals to 4 by 5. Therefore by definition of cross product we write here u bar cross v bar is equal to magnitude of u bar into magnitude of v bar into sin theta into m cap. Now we require the magnitude. So taking magnitude on both sides, u bar cross v bar is equal to magnitude of u bar is already here. So its magnitude is magnitude of u bar, magnitude of v bar is magnitude of v bar, magnitude of sin theta is sin theta, and magnitude of unit vector is 1. So we write 1 here. U bar cross v bar is equal to magnitude of u bar is 10, magnitude of v bar is 2, sin theta we calculate 4 by 5. So 5 2s are 10. So we get 2 2s are 4, 4 4s are 16. U bar cross v bar equals to 16. Magnitude of u bar cross v bar is equals to 16. So in this way, in first sub question we write there plus or minus because we calculate the value of cos theta, and cos theta is positive in first quadrant and cos theta is negative in second quadrant. So we write there plus or minus. Here sin theta is positive in first quadrant and sin theta is positive in second quadrant also. So from that we write this, or you can check the value. Cos theta equals to 3 by 5, and in previous example sin theta equals to 4 by 5, and we know the value of sin theta and cos theta for which quadrant we have to take which condition. So that we already discussed in inverse trigonometric function. So you remember that and you write the answer in this way. Now say question number 6. Prove that 2 times a bar minus b bar cross 2 times a bar plus b bar equals to 8 times cross product of a bar and b bar. So we consider here LHS. LHS is equal to 2 times a bar minus b bar cross 2 times a bar plus b bar. Now we take this 2 into 2, 4. Then we write a bar minus b bar cross a bar plus b bar. Now multiply these two brackets. So we write here a bar cross a bar plus b bar minus b bar cross a bar plus b bar. First we multiply by vector a, then we multiply by vector b. So here sign is minus. Now multiply by a bar. So we write here cross product. So we write a bar cross a bar plus a bar cross b bar. Then multiply by minus vector b. So we write minus b bar cross a bar. Then plus minus minus b bar cross b bar. Now we use the definition here. A bar cross a bar equals to 0 vector, and b bar cross b bar is equal to 0 vector. And again we can write a bar cross b bar as b bar cross a bar. Then we have to change its sign. So see here, this a bar cross a bar we replace by 0. This b bar cross b bar we replace by 0 vector. So we write directly here 4 times a bar cross b bar. This b bar cross a bar, since a bar cross b bar equals to minus b bar cross a bar, because cross product is not commutative. When we interchange the vector we have to change its sign. So we write this vector b bar cross a bar as plus a bar cross b bar. So we get here 4 into 2 times a bar cross b bar. So 4 2s are 8 times a bar cross b bar, which is equal to RHS. So in this way we prove the given problem. Now see next question, question number 7. If vector A equals to I minus 2j plus 3k, vector B equals to 4i minus 3j plus k, vector C equals to I minus j plus 2k, verify that A bar cross B bar plus C bar, here is print mistake in textbook. So A bar cross B bar plus C bar equals to A bar cross B bar plus A bar cross C bar. That means this cross product is distributive over B and C. We have to verify here. So first we find the LHS. So write in solution LHS is equal to A bar cross B bar plus C bar. So we have to find the value of vector B plus C. So first we find here B bar plus C bar equals to, now add vector B with vector C. Now see here, vector B is 4i minus 3j plus k, plus vector C is I minus j plus 2k. Now add the like vectors. 4i plus I, we get 5i. Then minus 3j minus j, we get minus 4j. K plus 2k, we get 3k. Now we have to find a bar cross b bar plus c bar. So we write here LHS is equal to, in first row we write ijk, in second row we write the coefficient of the ijk for first vector. So first vector is vector A, so we write 1 minus 2 3. In second row 1 minus 2 3. In third row we write coefficient of ijk for second vector. Second vector is b bar plus c bar, so we calculate here b bar plus c bar. So the coefficient of ijk are 5 minus 4 3, 5 minus 4 3. So calculate this vector, plus minus plus, so we write here I into minus 2 into 3 minus 6 minus, so minus minus plus, 4 3s are 12, then minus j cap into 1 into 3 is 3 minus 5 3s are 15, so 3 minus 15 plus k. 1 into minus 4 is minus 4 minus 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 plus 5 to the 10. So we get value of LHS as minus 6 plus 12, which is 6i. Here 3 minus 15, that is minus 12 minus minus plus, so we write here plus 12j. Then minus 4 plus 10, which is 6, so we write here 6k. This is value of LHS. Now we have to find the value of RHS. So for that we find value of a bar cross b bar first, then value of a bar cross c bar, then we add that, we get the value of RHS. So we first find a bar cross b bar. So write in first row I, j, k. Then coefficient of ijk for vector A, that is 1 minus 2 3. 1 minus 2 3. Coefficient of ijk for vector B, that are 4 minus 3 1. 4 minus 3 1. We have to calculate this. I into minus 2 into 1 is minus 2 minus 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 plus 3 into 3 9 minus j in bracket. 1 into 1 is 1, 1 minus 4 into 3 is 12. Then k cap into 1 into minus 3 is minus 3, then minus minus plus 2 into 4 is 8. So we get here minus 2 plus 9, which is 7i. Then 1 minus 12 is minus 11, minus minus plus 11j. Then minus 3 plus 8, that is 5, so we write here 5k. This is the value of a bar cross b bar. Then we have to find the value of here a bar cross c bar. Therefore a bar cross c bar equals to, again we use the determinant I as minus 2, 1 minus 2 3. Now see the coefficient of vector ijk for vector c. 1 minus 1 2, 1 minus 1 2. So write plus minus plus, which is equals to I in bracket minus 2 into 2 minus 4 minus 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 plus, so we write plus 1 into 3 3. Then minus j in bracket 1 into 2 is 2 minus 1 into 3 is 3. Then plus k cap in bracket 1 into minus 1 is minus 1 minus minus plus 1 into 2 is 2. So write the value of minus 4 plus 3, which is minus, so we write minus I. 2 minus 3 is minus 1 minus minus plus j. Then minus 1 plus 2 is 1, so we write here 1k. This is value of a bar cross c bar. Therefore RHS is equals to A bar cross B bar plus A bar cross C bar. Now you can directly add these two vectors. So see the value of A bar cross B bar as 7i plus 11j plus 5k, and value of A bar cross C bar as minus I plus j plus k. Now add these two. So 7i minus I, we get 6i. Then 11j plus j, we get 12j. Then 5k plus k, we get 6k. So from LHS and RHS we get the same value, or you can denote this LHS as equation number 1, RHS as equation number 2. So you can say from equation 1 and 2, therefore from equation 1 and 2, LHS is equal to RHS. So in this way we verify that A bar cross B bar plus C bar is equal to A bar cross B bar plus A bar cross C bar. That means this cross product is distributive over B bar plus C bar. Now see next question. Find the area of parallelogram whose adjacent sides are vector A and vector B. Now here, if vector A and vector B are the adjacent sides of this parallelogram, then area of parallelogram is the magnitude of A bar cross B bar. So we have to find first A bar cross B bar, then we have to take its magnitude. So we first find here in solution A bar cross B bar equals to, so write in determinant I, J, K. So we write the coefficient of vector A, coefficient of ijk in first row, in second row. So we write 2 minus 2 1, 2 minus 2 1. Then coefficient of ijk of vector B, that is 1 minus 3 minus 3, 1 minus 3 minus 3. So calculate this determinant. So we write here I cap into minus minus plus 2 into 3 6 minus, again minus minus plus, so we write here 3 into 1 3. Then minus j, 2 into minus 3 minus 6 minus 1 into 1 1. Then plus k cap into 2 into minus 3 minus 6 minus 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 plus, so we write 2 into 1 2. So write this as 9i minus 6 minus 1, that is minus 7 minus minus plus 7j. Then minus 6 plus 2 minus 4, so we write minus 4k. Now this is the value of A bar cross B bar. We have to take magnitude of A bar cross B bar equals to, so write the square of 9, that is 81, square of 7 which is 49, square of 4 which is 16. So add these three terms, we get 10, 16. We get under root 146. Now we have to find the area of parallelogram. Therefore, area of parallelogram whose adjacent sides are A bar and B bar is equals to magnitude of A bar cross B bar, which is here 146. Now this is area, so we have to write square unit. So in this way we find the area of parallelogram if adjacent sides of a parallelogram is given.